Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I am Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled on Monday through Thursday from 3 till 4 in the afternoon, and we are now in our 5th week of our 9-week course. At this point, you definitely should be submitting some work as we are almost halfway through our timeline. So a reminder that the key questions are all found at the back of each of your IL lessons. So please do all of them. Some of them are check your understanding questions within the chapter. Some of them are the activities at the end, and most of them include the review questions also at the end of each chapter. Remember to show all of your work, your steps, your thinking, explain everything. Don't just give me one-word answers, give me full sentences and full complete thoughts. And make sure you're actually answering the question. This way I'm able to understand what you truly understand. Then if you're struggling with something, it gives me more information so I can help clarify for you. You're welcome to do this by hand or electronically. If you want to write in the workbook, that's fine. They don't give you super large spaces, but if you'd like to, that's totally good. It's your workbook, so you get to keep it. If you'd like to do it electronically, that is also fine. The easiest programs for me to open are Word and Google Doc files. Everyone has access to Google Doc through your NNEC email address. If you need help with that, I'm happy to help you do that. If you're using a different program like Pages or something else, I'm sure that's fine as well. Just let me know so that I can make sure that I can open your files. There are 3 different methods for submitting your work. If you're writing it out by hand, then you can scan it in and then either way send it to me electronically. If you need to scan it, you can use a smartphone with either the iPhone Notes app or the Android Google Drive app. Both have scan functions, which just makes the file a little bit smaller and easier to read. If you just need to take a picture of it because you can't do that, that's fine as well. Then you can send it to me by either email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. Second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our building at 74 Front Street. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. And you're working to your DEC. Your DEC can send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. You can friend me on Facebook or subscribe to my YouTube channel, and then every time I upload one of our recorded lessons, you'll get a notification. So all of our lessons are recorded, and then I post them on YouTube shortly after airing, and I put them on a playlist called SVN3E. Also under that playlist, there's another playlist called supplementary videos, where all of the videos that I share in our class you can find. So you can get them from the original source, and then you can find more videos if you like that content creator, or if you're just looking for more information, you can go there and find that. Science is really visual. Personally, I think all learning is visual, but science, I try to incorporate as many diagrams and images and videos as I can in order to really round out our understanding. So accessing the videos is going to set you up for the most success. If you can't join me live through the Zoom link and you can't access the YouTube channel and watch the replays, let me know and I can send you a USB key or something with the recording, the copies of all the recordings, so that you can still have access to them and get the full experience as much as possible. If you have any questions or concerns, please reach out and contact me. I am reaching out to students right now to sort of let them know you only got 5 more weeks or so to get your final work in. All of your work needs to be in by June 10th in order to get your credits this term. So please reach out if you haven't heard from me, or if you have heard from me, it'd be great to chat. You can email me at bronwyn.slate, which is BRONWYN.SLATE at nnec.oed.ca. You can Facebook message me at bslatewahsa. You can call me on the phone at the office at 807-737-1488, extension 2209. My voicemail is working, so you can call me and leave you a message and I'll get it and get back to you. You can also call us toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 4 p.m., though I teach the first hour and the last hour of the day. So I'm not available at those moments, but I will get back to you, or you can connect with me within that time frame. All right, I like to start our classes off with my positionality, just in order to frame where I'm coming from as we dive into these topics. I have white stellar ancestry, I have white privilege, and that shapes how I've learned and how I'm treated in our world, which means that that shapes how I teach and what I understand and what I miss in terms of learning and education and science, as well as all the other things. But that I just like to acknowledge, as I may make mistakes, I may miss out on things, and I want to own that, and I want to improve. If there is anything that I could do better, please let me know. I live in Northwestern Ontario on the traditional territories of the Anishinaabe people, and I work towards honoring and recognizing the knowledge holders and wealth of wisdom in my area. It is a process, and I don't have it all figured out. I am not an expert in any size, shape, or form. I never will be, but I try to learn as much as I can from the community around me. This is my first time teaching this course, so I do have lots to learn and unlearn. I most likely will always have lots to learn and unlearn, but particularly as this is my first time, lots of things are new to me, and I'm doing my best to try to integrate other perspectives other than my own within the course, but I definitely am missing the boat, I'm sure. Hopefully not more often than not, but possibly. Also, our textbook is very Eurocentric. I've noticed that it potentially has some problematic language within it, and it also does definitely ignore Indigenous, Inuit, and Métis knowledges and experiences. I find this really troubling, as a lot of this information is really relevant and valid for both Indigenous, Inuit, and Métis peoples, as well as white and the global majority of people who live in Canada. It's really problematic to continue to be focusing on the white perspective and the European, centering the European as the knowledge holder or as the ideal. So that is problematic. I am continuing to try to integrate Indigenous, Inuit, and Métis experiences and knowledges as much as I can, but because I'm white, I don't have a deep understanding of them, and it is hard. I'll admit it is hard for me. So I'm doing my best. If anyone has any suggestions, I welcome them and encourage you to reach out and help me do better. All right, so we continue to be in Unit 3, where we're talking about environmental effects on humans. We have talked about how there are factors in our environment that cause diseases in humans. And now we're going to be learning about vaccines and other ways to protect ourselves from these factors. So we've learned about the factors and how they affect our bodies. And now in this lesson and our next lesson, we're going to be learning about keeping ourselves safe. So this is lesson 11 in your IL booklet. And so it's the medical and non-medical ways to protect yourself from environmental factors. Our learning goals are that at the end of this lesson, you'll be able to identify and describe medical methods of preventing against environmental contaminants, and you'll be able to identify and describe various non-medical methods for protecting against environmental agents. Our success criteria are that you can explain how vaccines strengthen our body's fighting mechanisms. You can explain how medicines keep us safe. You can describe the protecting factors of sunscreen, sun protective clothing, respirators, and hearing protection. So we've already learned about some common environmental factors like air pollution, UV radiation, and pathogens. And then we've learned about how our body reacts to them when they're exposed to it. So how our body processes those contaminants and how that can make us sick and what diseases we might get. But there are medical and non-medical ways we can protect ourselves. So we're going to look at a few examples today. We're not going diving deep into every possible way that we can protect ourselves, but these are some of the bigger key ones that are more accessible. So first, let's look at the medical protections. We're going to talk about vaccines. So people use vaccines to protect themselves from many of the pathogens that cause illness and sometimes even death. In Canada, most vaccines are injected into our bodies using needles. Scientists are also looking at new ways of giving vaccines through ingestion or inhalation through nose spray. Not everybody likes to be injected. That can be stressful for many people, and so possibly ingesting or inhaling vaccines might be easier for folks, but we're not there yet. Vaccines are also often called immunizations, needles, or shots when we're talking about them. Most of us have received at least one shot at one time in our lives. Chances are you've received shots for diseases like diphtheria, whooping cough, and polio. Not necessarily, but also in the recent environment of COVID-19, many folks probably have also received COVID-19 vaccination and possibly multiple shots. So you may never have even heard of diseases like diphtheria, whooping cough, and polio. In the 19th and early 20th centuries, they were really well known. So this is like 100 to 200 years ago. They struck hundreds of thousands of people in North America each year, and tens of thousands of people died from these diseases. So they were really rampant and common. But now hardly anyone in North America gets these diseases. And this change has happened largely because of vaccines. So here you can see on these charts that in 1924 to 1935, there was a lot of diphtheria reported cases in Canada. So this is rates per 100,000 population. So 80 to 90 people per 100,000 people. But then it significantly decreased in 1935, and then just down to 1955, it's basically non-existent. The same with whooping cough. Whooping cough was more prevalent, from 1935 to 1945. There was definitely many more cases, up to 180 or so, between 140 and 180 consistently for those 10 years. And then it's a little bit more, didn't get eradicated quite as quickly. And it still has some resurgences sometimes, but it's significantly less. Now we're looking at less than 40 people per 100,000. And then polio from 1949. So looks like sort of around 1952 or so, there were 4,500 cases. And then again in around 1960, there were 2,000 new cases. And then around 1965, and since then there have been none. So this is due to the fact that they've been really, really high, and then all of a sudden none for both diphtheria and polio, and then significantly reduced for whooping cough are because of vaccines. So more people are vaccinated against these and therefore not getting these diseases. Here is the current publicly funded immunization schedule for Ontario. So if your child is born in Ontario and qualifies for Ontario Health Card, I don't know how that works if you are not a resident of Ontario, but your child is born in Ontario. I'm not quite sure how that works. But anyway, for the majority of folks who live and grow in Ontario, these immunizations, these vaccinations are free, and in order to benefit the collective community health. Because if more people are vaccinated against these things, then nobody is getting these diseases, even of people who can't be vaccinated. So in the first year of life, there are multiple shots that little kiddos need to get. And so you can see here 2 months, 4 months, 6 months, and 12 months, and then 15 and 18 months, and then on until 4 to 6 years old is when the next ones are. So in that first 18 months, there are 6 visits that you need to take little people to either public health or your local doctor or nursing station and get these immunizations. And so then they there's multiple things in these shots. So at 2 months, they get 3 different shots, and one shot has the vaccine that covers diphtheria, pertussis, tetanus, polio, Haemophilus influenza. And then the second shot is pneumococcal conjugate, and the third shot is rotavirus. And then that same combination of those shots happens again at 4 months. And then at 6 months, it's just that first shot that they get. And then at 12 months, they get the pneumonia monoclonal one, and then a meningococcal conjugate, and then the measles, mumps, and rubella. And then at 15 months, they get chickenpox. When I was growing up, we didn't have vaccination for chickenpox. So I got the chickenpox, and now it is quite likely that my kids will not get the chickenpox ever, because we now have a vaccine for it. And so that isn't something that they'll get sick with. And then at 18 months, a booster for the diphtheria one from the first one. And then it just continues. So this chart shows, again, at 4 to 6 years old, what needs to happen. And then grade 7 students, they get those ones at school, the meningococcal and hepatitis B. And grade 8 students with cervixes get the HPV vaccination also at school. And then when youth are 14 to 16, they get another diphtheria one. And then every year, once babies are 1 and above, you can get your seasonal influenza, your flu vaccination in the fall. So this just shows you how many different diseases we have vaccines for, that we are medicating our children, so that they are likely to live stronger, healthier lives in the long run, because they aren't having to worry about these various diseases. So vaccines protect you against spreadable or infectious diseases that are caused by microbes. Microbes are microscopic organisms like bacteria and viruses, and vaccines work by taking advantage of your body's natural ability to learn how to eliminate microbes that attack it. So your body wants to do this. This is part of your immune system. Part of its job is to attack things that are not supposed to be there. So the parts of your body that do this are called your immune system. Sorry, I do that often. Some microbes are so powerful or virulent that vaccines are needed to help your immune system. So your immune system can't deal with everything all of the time, and that's how vaccines support them. So most vaccines contain microbes that have been killed or weakened, and they have been weakened so that they will not cause a disease when they are injected into your body. This is key for when many folks are concerned about vaccines, is because vaccines contain part of the microbes that we're fighting against. And so it seems scary to feel like you're injecting part of the sickness into your body, but the sicknesses have either already been killed or it's very, very weak and not going to get you sick. So vaccines don't make you sick. Your body might react to them. Your body probably will react to them because that's your body's fighting. That's your body's, the immune system learning how to deal with these microbes, but you're not going to get the full-blown disease. So after being injected with a vaccine, your immune system builds up antibodies to fight off the microbes. The antibodies attach to the microbes and render them harmless. Special white blood cells can then identify the microbes and kill them. These antibodies will stay in your body for a long time and will fight off the microbes in the future. So these white blood cells learn from the vaccine. They learn about what these microbes look like and how to protect you against them. And then if those microbes, if the disease does you come in contact with, your body already knows how to kill them off. So often your immune system will be able to fight off a disease for the rest of your life. Sometimes it will need what is called a booster shot of vaccine to reinforce its ability to fight off the disease. And that's why we saw that there were multiple on the chart that showed what youth get. Some of them you only got a shot once. Sometimes you had to get a shot more than once in order to build up your immunity to it. And that's why right now with COVID-19, many were getting booster shots or we're getting more than one shot in order to help our immune system to fight off the disease more efficiently. So once your immune system has been conditioned by a vaccine to resist the microbes that has caused a certain disease, you're said to be immune to that disease. Before vaccines, the only way to become immune to virulent diseases was to get the disease and survive it. This is called natural acquired immunity. Though many folks who got diseases that were life-threatening did not survive it and therefore did not become immune. Many just died. Vaccines provide artificial acquired immunity because you do not have to get the disease to become immune to it. So this way we get the immunity without getting sick and without potentially dying. So vaccines can protect both individuals and communities. So if a certain number of people within a community are vaccinated against a disease, the entire group becomes less likely to get it. This protection is called herd immunity. Herd immunity covers even those in the community who are not vaccinated against the disease. So this is maybe something you've heard a lot about in the recent years. So a vaccine protects one individual, but if there's multiple people in a community that are vaccinated, then the people who can't be vaccinated because they have a weaker immune system or because they are too young and they don't have, like right now, you can't vaccinate against COVID-19 for children under 5. They haven't figured out a good vaccine for that, for those size people yet. They're still working on it. So the more people who are able to vaccinate, that means that there's less likely that the disease is in those communities because there's less people for it to attach to, and therefore the people who can vaccinate are protected. So we're going to watch a video that, if you're able to actually watch it, is really, really good in terms of visually seeing what's going on. So if you're just listening on the radio today, go check out the YouTube video. I will link it in the show notes so that you can go and see this, because it really shows, I think it really clearly shows how vaccines work, which I think is really, really useful, as this can be really confusing for many folks. All right, just give me a second. It is giving me issues. Doesn't. Sometimes it likes to play my videos and sometimes it does not. All right, let's play it from the beginning.
To understand how vaccines work, it helps to look first at how the immune system works, because vaccines harness the natural activity of the immune system. Systems quick to recognize these invaders. This is because the proteins that show us on the bacterial cells are different shapes. So I really liked the
visual of the key sort of image. I think that's really useful to see how the proteins or the sugars on the bacteria have different shapes and how our bodies are looking for the right key to kill those bacteria, and how a vaccine generates gives you kind of like your body a practice run to develop what that right key is. So then when there's more of the bacteria, if you actually get in contact with the disease, then your body can already react and not have to look for the key that already has it on file. It's sort of one way to think about it. So that's vaccinations. There are many conflicting opinions, and vaccinations are definitely a hot topic in our society, particularly with the most recent experiences of COVID-19, and there are plenty of anti-vaxxers and differences of opinions, but hopefully that is able to give you some information about how vaccinations work or vaccines work. I think it's really important to be informed so that you can make a decision that is best for you and your community and your family and extended bubble, so that you're able to protect yourself the best that you can. So the next medical method that we're going to talk about in terms of protecting ourselves are medications. So sometimes vaccines are not available, or people can take medications to prevent diseases from occurring. They can also take medications to treat symptoms of a disease or to help cure diseases. So when traveling to areas of the world where malaria occurs, people can avoid getting the disease by doing two things. One, they can prevent mosquito bites by wearing long sleeve shirts and long pants, sleeping under mosquito nets, and using DEET based products, which repel and kill mosquitoes. Or they can take anti-malaria medication to kill the parasites that cause malaria. So malaria parasites in certain parts of the world have become resistant to certain medications, so it doesn't always work. So as a result, the type of medication a person takes depends on where they're traveling. No matter what type of medication a person takes, it will not provide 100% protection against the disease. Anti-malaria medications can also cause additional negative reactions called side effects, including nausea, headaches, and sleep disturbances. So malaria is just one example that we're talking about. This could be various other diseases that you take medications for, but malaria is a common one. And you can see, according to this map, the areas where malaria is prevalent compared to where it used to be. So the gray is where there's never really been malaria. That's the first part is gray. There never has been malaria. There isn't malaria, which includes Ontario, where we are. But everywhere else that's colored at some point has experienced malaria and potentially continues to experience malaria. So the yellowish orange, the lightest color, is where up until the 1900s, malaria was prevalent. There were lots of risk of malaria in all of these places. And this was 53% of the world's land surface. So that's over 50% of the places where people would live were at risk of malaria being infection. And then as we get closer and closer to darker to red and then finally to purple, we get less and less places. So now the purple is where malaria has been in 2002 and continues. So now it's down to 27% of the world's land surface. So 25% of what, or half of what used to be covered, like used to be areas that were malaria was a danger, no longer are due to medications and things just not protections and preventions. But now in northern parts of South America and in southern parts of, or in Central America and along the equator in Africa, a large part, most of Africa, and then India and Southeast Asia, and also the islands between the south of that and north of Australia, I cannot think of what that word, their word is right now, that my brain is just blanking, are all areas that malaria is still present. So that is significantly less, but still a lot of places. So then this shows the global malaria deaths by the world. So remember in the map showed the purple places where malaria still is an issue was from 2002. And so this graph is showing the deaths in the world in since 2000. So to 2020. So think before this, it would have been more because there were more places that malaria was an issue. And the colors that are how the colors work is that the bottom color, this darkish pale red, if that makes any sense, is Southeast Asia. Then Mediterranean. Oh no, sorry, that's Africa. I was like, that doesn't make any sense. This big part is Africa. Then this bright pink is Southeast Asia. Then the Mediterranean. Then the bluish green is the Western Pacific. And then the Americas are on top, which is very, very small. So we can see that Africa is the place that is hit the most, and for having over 80,000 deaths related to malaria. And now in 2020, that being closer to 60,000, which is an improvement, but still a lot of deaths. Africa is really the place that is hit the most with malaria, and everywhere else is significantly less. So I found this TED Talk video. I'm a fan of the TED Ed videos about how your body processes medicines. And so this I thought was really useful in terms of understanding how your body actually deals, how you swallow a pill and you take ibuprofen or Advil or something like that, and it deals with whatever the pain or whatever you need to deal with. This talks particularly about ibuprofen, but the same principles apply to other medications and how your body deals with how your body processes other medications. So I thought that video was really helpful in terms of understanding how your body processes medication, and like how it also your body responds to like your pain receptors sending out that signal, and that's how that the medication, it's not like the medication is attracted to that spot, but that when it gets to that spot, then it's connects to those to fill in that void. And then also the fact that our bodies are constantly changing, how that has an impact on the effectiveness of medication is really important to recognize. So at this point, you should be able to do the check your understanding questions on page 88, questions 1 and 2. And now we're going to look at non-medical protections. So vaccines and medications were 2 medical methods, and now we're going to look at some non-medical. So first, we're going to look at sunscreen and sun protectors, protective clothing, which is so key for right now as we are coming into spring and summer, and now is prime time for many folks to get sunburns. So many people use sunscreen to protect themselves from sunburn. And most sunscreens have an SPF, a sun protection factor, on the label. So the SPF represents the length of time that sunscreen protects the skin that's exposed to UVB rays before it turns red, compared to the length of time it takes on unprotected skin. So that's a little confusing. So for example, if your skin burns after 30 minutes in the sun without protection, then an SPF of 15 sunscreen would allow you to spend up to 450 minutes, which is 15 times longer, in the sun without getting burned. So 15 times 30 is 450. So that's what an SPF of 15 means. But SPF only refers to the protection of UVB rays. If you remember back to the electromagnetic spectrum and how we talked about UV rays, how there's UVA and UVB and UVC rays. UVC rays generally don't get to the earth too much, which is great. And UVB rays are getting more and more and are stronger than UVA rays. So this protects against them, but UVA rays still do have an impact on our skin. So many sunscreens offer broad spectrum protection. So this means that they protect against both UVB and UVA rays. So a broad spectrum sunscreens usually contain chemical filters that absorb UV radiation and release it as heat. They can also contain small particles of zinc oxide or titanium dioxide that scatter and reflect UVB and UVA rays. Then another way people protect themselves is by wearing UV radiation. Not wearing it. By protecting themselves from UV radiation is by wearing sun protective clothing. So this is usually rated with a UPF, which is ultraviolet protection factor. Unlike SPF, UPF measures protection from both UVB and UVA rays. Lots of acronyms. So clothing is considered sun protective if it has a UPF of at least 50. So here is a chart that compares the two. So SPF sunscreen, again, only applies to UVB rays and must be applied on the skin before heading out. So it always says on the bottle, apply this 15 minutes before going out, which I almost never remember to do. It needs to be reapplied after sweating, swimming, or toweling. It can be rubbed off or washed off. It can be tricky to get full coverage I don't know if anyone else has experience, but I have definitely have many a time. I'm a person who burns really easily, and I will have covered most of my back, but then missed one little area and have one triangle of uh, a intense burn because I haven't got full coverage. It needs to be reapplied every 2 hours, even if you haven't washed it off or toweled it off. It just needs to be reapplied because it soaks into your skin or absorbs in your skin, or just gets wiped away. And SPF of 15 protects your skin from burning 15 times longer than no sunscreen. Whereas UPF and UPF clothing, so it applies to both UVA and UVB rays, is effective as soon as you put it on. As soon as you put the clothing on, you're good to go. It won't sweat off or wash off in water because it's clothing. It provides less risk of missing spots or publication because you're wearing the clothing properly. You're likely to know that. It doesn't need reapplication because you continue to wear the clothing. And a UPF of 50 continuously blocks 98% of UV rays. So UPF clothing is the better way of protecting your skin than sunscreen, as you're going to have more protection. So then in sunscreen, these are the types of ingredients that can be in sunscreen. So the physical things that reflect, like we talked about, actually reflect UVB and UVA, or UVB rays, are titanium dioxide and zinc oxide. And so these are usually the thicker like creams or sprays. They have them as sprays now that are usually super, super white and hard to rub in all the way. So they're safer for sensitive skin types and less likely to cause irritation. So if you have skin sensitivity, usually finding one with these filters is going to have like less chemicals and going to protect you better. It can have a look of white cast, so it can be hard to rub in, and you can end up having a pale look like you have pale cream all over your skin. And it does protect against UVA and UVB rays. Whereas a chemical one, which is probably the more common one, has various benzoin, various different chemicals. It generally is thinner and clearer, so it doesn't seem to stick on your skin. You might not feel it as much. People can react to them. So, and it varies in terms of what rays it protects you against. In this other picture, we see here as a family where they're all wearing UPF clothing. So you can see that they have long sleeves and long legs, or ranging from shorts to long, depending on the size of the person. And then the hats, some hats as well. So you can see that most of the skin is covered and protected by, even though these people are playing in the water, protected from the sun. And here's just an SPF rating. So SPF 15 is 93% of a sun filter. 30 SPF is 97% sun filter. SPF is 50 is 98%. But then you can also get like SPF 100, which is possibly just marketing. There's not actual science behind it saying that that is better, because at 50 you're already at 98% and you moved up 1% from 30. So it's never 100%. So that it's how long it stays effective is on your skin. That's what matters, not necessarily just the number. And then comparing that to the USP rating scale. So a UPF rating of 15 to 24 is good. You block 93 to 95.9% of UV radiation. SPF 25 to 39 is very good. 96 to 97.4, or UPF 40 to 50 plus is excellent. You're blocking 97.5 to 98% UV radiation. So both sunscreen and UPF clothing can give you a lot of protection. Just a matter of what works best for you. And if you can maintain reapplying and the timing of it, then maybe sunscreen is great for you. If that's not possible, then wearing clothing is probably a better bet. All right, so that's sun protection. Now we're going to look at respirators. So respirators are protective devices that are worn over the mouth and nose to protect the user from contaminants in the air. They can also be worn over the entire face or head. Firefighters, construction workers, healthcare workers, and others who come in contact with airborne hazards are more likely to wear respirators. This is fairly common. So there's two types that we're going to talk about: air purifying respirators, APRs. And here is an image of someone wearing one. So these use filters to remove airborne contaminants like particulate matter from the air. Other APRs absorb chemical gases and microbes in a cartridge or a canister. So they're taking things, they're filtering it out. Most APRs depend on the user drawing in surrounding air as they inhale in their mouth or the face mask. So you're breathing it in, and it's like you're breathing in the contaminants, but they're getting caught in the filters in the mask. Some APRs have air blowers to help move the air into the respirator. Then we have supplied air respirators, and this is an image. There's various different kinds, just a couple images that I found. So the SARs is what they're called. So SARs supply the user with clean air from a compressed air tank or through an airline. So instead of breathing in and filtering out contaminants, you're just breathing in clean air from compressed air. So they are more often used in extremely hazardous environments where you can't breathe the air. It's really dangerous to breathe the air. So they allow firefighters to work in burning buildings filled with smoke. So an air purifier or an air filter would just get really clogged and it wouldn't help at all. So this firefighters take their air in with them so that they can continue to breathe. They are also used when there are toxic industrial contaminants in the air that are life-threatening. So those are the two kinds of respirators that are most common and should be used if you're in those environments. And then finally, we're going to talk about hearing protectors. So hearing protectors are often used in workplaces to reduce their exposure to noise pollution and the risk of hearing loss. So people choose to wear different protectors based on the noise level and how comfortable the protector is to wear. There are two main types of hearing protectors. There's the earplugs, usually made of foam, that are inserted into the ear canal and block sound. Then they are earmuffs that are made up of sound reducing material and soft cushions that cover your outer, they're covered by hard caps over your ears. And they can be both worn together. In some places, some folks wear both of them for the most protection. So here are some images of earbuds. They come up, you can have them attached or just little separate ones. Advantages of the earbuds or earplugs, are that they're small and easy to carry. They're simple to use. They're less expensive. They're convenient to use with other equipment. So they can be worn with earmuffs, or if you're wearing goggles or whatever, various things on your face, on your head, helmets, they can be easy to use. They can be more comfortable to wear in hot, humid work areas because they're less, they're not covering more skin. They're just in contact with your ear canal. The disadvantages are that they provide less noise protection than earmuffs. You can get custom molded plugs, but they require more time to be properly fitted. They can be more difficult to insert and remove. They must be properly inserted to provide effective protection. So I've many a time put an ear plug into my ear and I haven't done it properly, and so that doesn't really work. They require good hygiene practices to avoid dirt and bacteria entering your ears, causing ear infections. They could irritate your ear canal, and they're easy to misplace because they're little things, so you could just lose them. The advantages of the earmuffs are that they're more consistent noise reducing ability among different users. So various people can wear something similar or the same, and it's going to be effective. They're designed to be a one size fits most head sizes, so you don't need to get them personally fit. They're more durable and have replaceable parts. They're easily seen at distance to assist monitoring their use, so you can tell if you're wearing them properly or not. They're not as easily misplaced or lost because they're big and bulky, and they're more worn with minor ear infections. They generally don't, because you're not putting them in your ear, you're less likely to get bacteria or dirt in your ear because of them. Disadvantages are they're less portable and heavier to wear because they're big and bulky. They are more expensive because there's more to them. More inconvenient to use with other personal protective wear. So if you're wearing safety glasses or prescription glasses, it could break the seal, or it could just be, could not work very well. And they can be uncomfortable to wear in hot, humid working areas. They can get your ears all sweaty, has been my experience. So they're both good options depending on your situation. You have to decide for yourself. All right, now you can do the check your understanding questions on page 91, 1 and 2. All right, we are right at the end of our time, so we'll quickly go through this, that our medical protections were vaccines and medicines. Our non-medical protections were sunscreen, sun protective clothing, respirators, and hearing protection. So hopefully now you can explain how vaccines strengthen your body's fighting mechanisms and how medicines keep us safe, along with how sunscreen, sun protective clothing, respirators, and hearing protection are all protect us against factors. The review questions are on page 93, 1 to 13. If you have any questions or concerns, please reach out as always with usual methods to get a hold of me. I'm happy to chat with you about all of these issues and support you to get through your coursework. I hope you have a lovely day and miigwech.